Now we want to have a look on the graph of vapor pressure versus composition curve of ideal solution. Ideal solution here will follow Raoults law. Okay, this is the graph. Okay, how to read this graph? Okay, we have three straight line if you can see here. Okay, the red one is the vapor pressure of benzene. The blue one is vapor pressure of toluene. The black dash one, okay, is the total vapor pressure and liquid composition. So this is liquid composition, which is P total here, and the curve one, the green curve one, is the vapor composition. Okay, on the y-axis there will be vapor pressure. This one is vapor pressure of toluene, and here will be vapor pressure of benzene. The mole fraction of the benzene and toluene. So here will be zero benzene. Here will be 1 benzene, and also 0 toluene, and here will be 1 toluene. Okay, so each pressure on this black line is the sum of the pressure on the two straight line that lies below it. So meaning 1.1 plus 0.2 is equals to 0.3. From the 0.3, we can draw a straight line we call as tie line, and we got 0.4. Okay, at this 0.4, we can see the composition of pure benzene and toluene at this 0.4, which is this is the point where vapor in equilibrium. Okay, so at 0.4, for example, here we have 0.7 benzene and 0.3 toluene. So always remember that benzene is more volatile compared to toluene. So the benzene has a greater tendency to escape as a vapor. That's why at the equilibrium, okay, we have mole fraction of benzene, which is 0.7, okay, higher compared to mole fraction of toluene, which is only 0.3. Okay, so 0.7 plus 0.3 is equals to 1. So the vapor phase is richer in the more volatile component than is the liquid phase. Okay, so the liquid phase, it is 0.5 of benzene and 0.5 of toluene. But in vapor phase, which is at equilibrium, we have benzene, rich of benzene compared to toluene, as a benzene is more volatile compared to toluene. From the graph, boiling point versus composition curve of an ideal solution, the figure shows the equilibrium between liquid and vapor of an ideal solution. So the mixture here is mixture of benzene and toluene, whereby benzene has boiling point 80 degrees Celsius and toluene has boiling point of 110 degrees Celsius. When the mixture undergo distillation, as the temperature increase above the boiling point of benzene, which is 80 degrees Celsius, repeating boiling and condensation, at the end of the distillation process, the pure benzene is obtained as distillate or known as condensate. So condensate is liquid form when steam passes from the vapor to the liquid state. Fractional distillation process is a process of separating the components or substances from a liquid mixture by using selective boiling and condensation. We need to understand the term distillate and residue. So distillate is a pure liquid collected as a result of condensation from distillation process. And residue is a liquid that has higher boiling point and remain as liquid after the distillation. From the example mixture of benzene and toluene, we know that the boiling point of benzene is lower compared to boiling point of toluene, which is 110 degrees Celsius. So when it goes distillation, the benzene will be evaporated and the vapor of benzene will go through the condenser and it will uh, undergo condensation, and pure benzene can be collected as distillate or condensate. The toluene has a higher boiling point, will remain as a residue. If there are three components, the fractional distillation produce first distillate, second distillate, and residue. The figure shows a boiling point versus composition graph for water ethanol system. We know that the boiling point of water is 100 degrees Celsius and the boiling point of ethanol is 66 degrees Celsius. When the temperature increase, whereby at the composition of 20% ethanol, the vapor at point E will condense to point F at around 90 degrees Celsius. The liquid at composition F will boil again and produce vapor at composition G, and then repeating the distillation process until pure ethanol obtained at its pure boiling point, which is 66 degrees Celsius.